What is that spiral arm in the center of the Milky Way? You already know that we inhabit a planet called Earth that revolves around a star called the Sun and a galactic center called the Milky Way. We are located roughly 8 kiloparsec away from it, which is extremely close relative to the distances we are accustomed to, but is still quite a distance when you consider the vastness of the universe. For instance, the megaparsec, which is equal to 10 to the 6th parsecs or 10 to the 3rd kiloparsec, is used to measure the distance between galaxies. The Sun is situated in the Orion Arm, a smaller spiral arm sandwiched between two larger arms, at a distance of 8 kiloparsec, or around 1/3 of the distance from the Milky Way galaxy's center to its farthest boundaries. The Milky Way is actually a spiral galaxy, so-called because of the spiral patterns that run from the galactic center outward into the disk. The young, hot OB stars that reside in the spiral arms, which are locations of active star formation, make them brighter than the disk around them. The relatively well-defined orientation and spiral arm shape of a spiral arm orbit are frequently caused by the stars and gas that make up its population's cinematic characteristics. In other words, it is reasonable to believe that we are aware of the direction and trajectory of a spiral arm in our galaxy. One of the spiral arms of our galaxy, which is around 4,000 light-years away from Earth, may be sticking out at an odd angle, according to a recent discovery. They refer to it as a break in one of the spiral arms of the Milky Way. To learn more about this unplanned break, follow me in this video. Picture yourself isolated in the middle of a jungle. There are many types of trees all around you, and you need to move quickly because it will soon be night, and staying there after the sun has set would be extremely dangerous. How would you know where the exit is? You could ask a friend who was observing you from above to lead you out of there, because he would have complete control over the area. But let's say you don't have any buddies. You are likely going to be stranded there unless you are extremely lucky or unless you are Bear Grylls. As you are unable to distinguish between the forest and the trees, you are unable to get a top-down perspective. Well, scientists encounter a similar predicament while trying to understand how our galaxy works. There are times when the galaxy is obscured by the stars. As we are inside the Milky Way, we are unable to see the entire constellation that surrounds us. Because of this, it is challenging to comprehend its characteristics and features. And it indicates that fresh discoveries are probably about to be made when a group of astronomers begins closely scrutinizing a certain region of our galaxy. That's why it didn't come as a surprise to astronomers from all over the world when we discovered a rift in one of the Milky Way spiral arms. What is it then? The Sagittarius arm of our Milky Way galaxy is where this split originates, and it has an odd direction. This is the first significant structure documented with such a severe orientation, although other spiral arms do exist with very odd orientations. On July 21, 2021, the researchers made their discovery public in the peer-reviewed journal Astronomy and Astrophysics. Let's attempt to pinpoint the location of this break. We may claim that the Sagittarius spiral arm's fragmented region spans for roughly 3,000 light-years at a sharp angle from the main arm, and that the tangent to the spiral arm's origin lies at a galactic latitude of about -17 degrees. But, as we are not astronomers, these data don't provide much insight. If we discuss things in terms of constellations, perhaps things become more evident. As we look at the Milky Way flowing behind these stars and the constellations Sagittarius and Serpens Cauda, we are looking towards that area of the sky. The most notable celestial objects can be found in the spiral arm break, including several stars and nebulae. One of these is the Eagle Nebula, famous for the Pillars of Creation image taken by the Hubble Space Telescope. Moreover, it contains the Lagoon Nebula, Trifid Nebula, and Omega Nebula. These nebulae are frequently captured in the same shot. Now that we're here, you get it. Let's examine how researchers discovered the breach, given that we are aware of what it is and where it is. Of course, they required a telescope, or, more accurately, they required information obtained through a telescope. They focused on NASA's Spitzer Space Telescope as a result of this. NASA's Spitzer Space Telescope, the organization's fourth and last component to its Great Observatory program, was launched in 2003. In order to enable astronomers to investigate the universe in this crucial region of the electromagnetic spectrum of light with unparalleled clarity and sensitivity, Spitzer was designed to become NASA's leading infrared light observatory. As a result, they examined a ton of information about nascent stars that the telescope's infrared vision had discovered lying inside these nebulae. In order to determine the exact distances to the stars, they also used data from the ESA's Gaia spacecraft. Gaia is a crucial tool that will help astronomers from all around the world gain a deeper knowledge of the universe as a whole and the environment in which we live. Because of its accuracy, several astronomers began utilizing the data before they were approved. Distances are among the hardest things in astronomy to measure, according to Alberto Cromartins from the University of California, Irvine, who was one of the study's authors. The shape of this new structure is only now becoming so clear because to recent, direct measurements from Gaia. Combining the two sets of data showed that the young stars in the fractured section of the Sagittarius arm are traveling through space in the same general direction and at about the same speed. They discovered a great deal of complexity in this area that had previously gone unnoticed when scientists combined the data from Gaia and Spitzer to create this intricate, three-dimensional map. The reason why all of that star material develops into these spiral arms is still a mystery to scientists. Astronomers have reportedly found groupings, local groups, and clusters of more than 100 billion galaxies, but for the reasons we've already discussed, they haven't been able to fully model and map our own Milky Way galaxy. Now that we are aware of the method by which this discovery was accomplished, let's attempt to explain why the break is significant. Make sure to like or dislike the video before learning the answer to this query so that we can keep improving and making these films better for you. Moreover, be sure to click the bell to subscribe to the channel so that you don't miss any of our weekly videos. You'll discover something fresh today right here. A unit known as a pitch is used to measure the length of a spiral galaxy's arms. If a spiral is twisted so tightly that it forms a circle, the pitch is said to be 0 degrees. Instead, the pitch rises if a spiral arm opens. An important characteristic of spiral arms is, in fact, how tightly and at what pitch they wind around a galaxy. We determined that the Sagittarius arm should take the shape of a spiral with a pitch angle of roughly 12 degrees after analyzing the structure of the Milky Way galaxy and applying all the physics we are aware of to our best stellar models. Yet, these were only models. The issue as well as the astoundingness of this discovery arose when they discovered that the structure they had been looking at really sticks out at an angle of about 60 degrees. There is a significant difference with models. That is a sizable pitch. This spiral arm is incredibly slack. This is the first time a structure like the jetting fractures observed in spiral arms of other galaxies has been found in our own galaxy. This is a significant finding that undermines our best models and urges us to re-examine our assumptions as well as take fresh, in-depth measurements of the velocity of individual stars. The spiral arm break stars likely developed in unison. They were probably influenced by internal Milky Way forces, including gravity and shear from the galaxy's rotation. This finding serves as a reminder that there are still a lot of unanswered questions regarding the Milky Way's large-scale structure. To put it another way, we must study every single tree in the forest in order to understand the forest's larger image. Good fortune! Although this structure only makes up a tiny portion of the Milky Way, it may provide important information about the galaxy as a whole. As you can see, reality continues to astound us. It is always far more complicated than we realize, and the only thing we can do is continue to observe it and make an effort to comprehend it a little bit better. We are putting together our understanding of the universe piece by piece, tree by tree, and star by star. It is occasionally hazy and then becomes clearer. But the puzzle is a sizable one, the forest is a disorganized one, and the cosmos is an odd one. As always, our only option is to maintain its curiosity. Here's where the video ends. Thank you everybody for watching. What is the strangest thing you are aware of about it? Do you have any questions or other requests? Please share your thoughts in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.